Okay guys, so let's discuss the questions related to JEE Main pattern exercises for the chapter Introduction to 3D Geometry. The first question says, in this figure, the coordinates of point D will be what? So if you can see, there is this point B in space, a perpendicular is being drawn and it is stopped at the XY plane, right? Now the point D is completely lying in the XY plane, therefore its Z coordinate will be 0. Its Z coordinate will be 0, moreover because I am drawing a perpendicular and stopping at the XY plane, nothing is going to happen to the X and Y coordinate. They are going to exactly remain the same. The only thing which is going to change is the Z coordinate, and therefore you are going to have A, B, 0 to be the coordinates of point D. That's something very basic, okay? Moving on to the next question. Again it says in the same figure, in the same very figure, if the coordinates of point P are A, B, C, then the reflection of P in the XY plane, YZ plane, XZ plane will be what? Now when I am talking about reflection of P, again I am saying that you need to drop a perpendicular from P onto the XY plane, or basically I can say you need to drop a perpendicular and go the exact same distance downward as much as you are upward. So how much are you upward? C units. Along the z-axis you are going upward, right? If I am talking about its projection or reflection in the xy plane, right? So you are at what height? C units. The same height you need to travel below, right? Below the xy plane. So that means the point is only changing its height. Nothing else is going to change. Right now it has A, B and C as its coordinates. Now if I talk about its image along the xy plane, it is going to be A, B, minus C. So the image of P in the xy plane, image of point P along the xy plane, you can say, will be only the change in the height. It will just be the same height but in the downward direction. So same height in the downward direction will be minus C then, the coordinate. So it will be A, B, minus C. Exactly in a similar fashion, when I am talking about its very reflection along the XZ plane, in that case what is going to happen is the same distance as it is covering along the y-axis, the other side, wherever the image is, the same distance will be covered on the other side along the y-axis. Apart from that, x and z coordinate are not going to change at all. So when you are talking about the reflection of P along the xz plane, only B is going to be changed to minus B, rest A and C are going to remain the same. So along the xz plane, B will change to minus B, A and C will remain the same. Okay? And now you understood the idea. If I talk about the image along the YZ plane, in that case what is going to happen is only the x coordinate is going to change. Change means what? If it is 2 units along the x-axis, then minus 2 will be the units covered along the x-axis by the image. Right, so that is only the thing that is going to change. So along the YZ plane it will be minus A, B, C. Okay, so along the XY plane we are getting A, B, minus C. Then along the YZ plane we are getting minus A, B, C, and along the XZ plane we are getting A minus B, C. This is the correct option. Okay. Moving on to the next question, we have the point which is equidistant from this point O, A, B and C has what as its coordinates? So let's see, distance formula coming into picture. There is a point, say P. It is equidistant from O, it is equidistant from A, from B, from C. That means P's distance from O is same as its distance from A. O is 0, 0, 0 and point A is small a 0, 0. Now OP is same as AP. So clearly OP square is same as AP square. What is OP? It is x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. And what is AP? AP is x minus a whole square plus y minus 0 whole square plus z minus 0 whole square. So obviously y square z square gets cancelled. You have x square equals x square plus a square minus 2ax. So you have 2ax equals a square, which implies 2x equals a, or x is a by 2. The moment you have x equals a by 2, you can use another very thing, that OA is also, or I should say OP is also equal to BP, right? This is going to give you that y coordinate is equal to b by 2, and when you use OP is equals to CP, you are going to get z coordinate to be equal to c by 2, and therefore by these three relations, one is we used OP is equal to AP, that gave us the x coordinate, then OP is equal to BP, that is going to give you the y coordinate as b by 2, and OP is equals to CP is going to give you the z coordinate as c by 2. So you have a by 2, b by 2, c by 2 as the coordinates. The next question says, if the extremities of the diagonal of a square are given to you, then the length of the side is what? Okay, let's see. So whenever you have a square with you, you should know that if this is the diagonal, then diagonal's length is root 2 times the side's length, one side length. The diagonal length is root 2 times the side length. Okay? What is the diagonal length? Now see, the extremities are given to you. What are they? 1 minus 2, 3 and 2 minus 3, 5. So if I say this is A, this is B, what is AB? That is the length of the diagonal of the square. It is under root 1 minus 2 whole square plus minus 2 plus 3. Minus 2 plus 3 means 1 whole square plus 3 minus 5 whole square. So this gives you root 6. Diagonal's length has come out to be root 6. You are wanting the side's length. It is root 6 by root 2, which is nothing but root 3. So one side is of length root 3. It's a square, so each side is of length root 3, and therefore root 3 is the correct option. Now if I move ahead to the next question, we have the point in the xy plane which is equidistant from 3 points A, B and C has what coordinates? Let's see. So there is a point in the xy plane. The very fact that the point is in the xy plane means that its z coordinate is 0. It is equidistant from 3 points A, B and C. A is 2, 0, 3, B is 0, 3, 2 and C is 0, 0, 1. You know that if I say this is P, you know that AP is equals to BP is equals to CP. So first I am going to use AP is equal to BP, and therefore their squares are also same. Then you have A minus 2 whole square plus B minus 0 whole square plus 0 minus 3 whole square. This is equal to BP. So BP square, that means A minus 0 whole square plus B minus 3 whole square plus 0 minus 2 whole square. This gives you what? A square plus 4 minus 4A plus B square plus 9 equals A square plus B square plus 9 minus 6B plus 4. Okay? A square, B square, A square, B square gets cancelled. You have minus 4A plus 6B. Minus 4A plus 6B. 4 plus 9, 13, 4 plus 9, 13 gets cancelled out. You are left with what? 2A minus 3B is 0. isn't it? This is minus 2a plus 3b, or you can say 2a minus 3b. Similarly, if I say PB, or I should say BP is equals to CP, squares are also same. BP will be a minus 0 whole square plus b minus 3 whole square plus 0 minus 2 whole square is equals to CP, that is a minus 0 whole square plus b minus 0 whole square plus 0 minus 1 whole square. A minus 0, b minus 0, 0 minus 1. So this is going to give you a square plus b square plus 9 minus 6b plus 4 equals a square plus b square plus 1. Again, this gets cancelled out. What are you left with? You have 9 plus 4, 13 minus 1, 12 minus 6b is 0. So you get b is equal to 2. The moment you put b is equal to 2, you get 2a minus 6 is 0. A is 6 by 2, that is 3. And so the point is 3, 2, 0. Easy enough, just the direct use of distance formula, nothing else. Next I have, let A be this point and B be this point. There be 2 points and C is a point on AB produced such that twice of AC is thrice of AB. Then what are the coordinates of C? Okay, let's see what the question is trying to say. This is A is 2, minus 1, 4. Then there is B, which is 0, 2, minus 3. And on AB produced there is some point C, such that it is saying that twice of AC is thrice of AB. Somehow the section formula is being actually signaled to pop up. I am going to manipulate this expression. AB can be written as AC minus BC. AC minus BC. This is twice of AC equals thrice of AC minus thrice of BC. So this gives you 3AC minus 2AC is AC, and this is 3BC. So you are getting AC by BC is 3 upon 1. So you are getting AC by BC is 3:1. So C is dividing AB externally in the ratio 3:1, right? C divides AB externally in the ratio 3:1. The moment we have this information with us, now we are very, very thorough in getting the coordinates of point C, which is the dividing point. Let this be x1, y1, z1. What will be x1? X1 will be what? 3 into 0, 3 into 0 minus 1 into 2 upon 3 minus 1. Y1 will be 3 into 2 minus 1 into minus 1 minus 1 into minus 1 upon again 2. And you have Z1 as 3 into minus 3, 3 into minus 3 minus 1 into 4 upon again 2. So you have, what is this? This was what? 3 into 0 minus 1 into 2, that is minus 1, 7 by 2 minus 13 by 2. These are the coordinates of point C. You have minus, so neither this nor this nor this. So basically none of these is the correct answer, right? Here you should have 7 by 2 and not 4, because here what we do is we basically take 3 minus 1 and not 3 plus 1. That happens in internal division. So you have 3 times 0 minus 1 times 2 whole upon 3 minus 1. Then you have 3 times 2, which is 6, minus 1 times minus 1, which is plus 1, whole upon again 3 minus 1. And in the last you have 3 into minus 3, which is minus 9, minus 1 into 4, which is minus 4. So minus 9 minus 4 whole upon again 3 minus 1, that is 2, and that is how you get the coordinates of point C. Now moving ahead, we have the next question, the ratio in which the line joining these 2 points is divided by the xy plane. Okay, so let's see. So 2 points are given. There is this point A and there is this point B, 1, 2, 3, and then we have minus 3, 4, minus 5. And xy plane is actually dividing this point, suppose at point R. So if xy plane is dividing the very line segment joining A and B at point R, that means this point is lying on the xy plane. If it is lying on the xy plane, obviously its z coordinate is 0, right? Let it divide in the ratio lambda is to 1. So coordinates of R are what? Minus 3 lambda plus 1 whole upon lambda plus 1, comma 4 lambda plus 2 whole upon lambda plus 1, and you have minus 5 lambda plus 3 upon lambda plus 1. But the z coordinate is actually 0 of this point R, right? I just applied the section formula, nothing else, but then the z coordinate is 0. So you get minus 5 lambda plus 3 upon lambda plus 1 is 0. That means this is 0. So lambda will be what? Minus 5 lambda is minus 3, lambda is 3 by 5, and therefore 3:5 is the ratio in which xy plane is going to divide the line segment joining A and B, that too internally. 3:5. Next question we have, in triangle ABC, midpoints are given to you, and then there is an expression whose values is asked to be computed. Now for this, let me just tell you a small concept. So this is A, this is B, this is C. Midpoint of BC is given to you as x1, y1, z1. This midpoint is x2, y2, z2. And this midpoint is say x3, y3, z3. When you are aware about midpoints of the 3 sides of this triangle, you can very easily get the coordinates of the vertices. What is that? Just the opposite one. Minus x1 plus x2 plus x3, comma minus y1 plus y2 plus y3, comma minus z1 plus z2 plus z3. B will be what? B will be x1 minus x2 plus x3, y1 minus y2 plus y3, z1 minus z2 plus z3. And what will be this? x1 plus x2 minus x3, y1 plus y2 minus y3, z1 plus z2 minus z3. That's how you can get the coordinates of the vertices as well. Right now I am given what? Let's look at the situation. So this is A, this is B, this is C. You are given the midpoint L, 0, 0. This is 0, m, 0, and this is 0, 0, n. So what will be the coordinates of A? A is going to be minus 0 plus 0 plus L, minus m plus 0 plus 0, and minus 0 plus n plus 0. Similarly, B will be L, m, minus n, and C will be minus L, m, n. Now it is asking us to compute AB square plus BC square plus CA square. What is AB square? AB square is L minus L whole square 0 square, m minus minus m. So 2m whole square plus minus n, so again 2n whole square. So this comes out to be 4 times m square plus n square. This is AB square. AB square, then you have BC square. BC square, this is 4L square. Then m minus m will be 0. n minus minus n 4n square. And similarly you have CA square, CA. So again minus L that is L square, so it will be 4L square. Then what is this? M minus minus M, so again plus M square, that is it. So now when you add basically according to this expression, you get 4 common, L square, 4 is coming out common, you can see, M square plus N square plus L square plus N square plus L square plus M square. So you are getting L square plus L square, that is twice of L square plus twice of M square plus twice of N square, which basically makes it twice of L square plus M square plus N square, whole upon L square plus M square plus N square, and that gives me 8 as the answer. Clear? That's what is your answer. So just keep in mind this concept. When you know the midpoints, you can get the coordinates of the vertices as well. Apply it, apply the distance formula, and you have your ready answer. Now moving to the next question, what does it say? It says that if a line makes alpha, beta and gamma angle with the coordinate axis respectively. Okay, so if it is making these angles with the coordinate axis respectively, then what is the value of cos 2 alpha plus cos 2 beta plus cos 2 gamma? Now see, over here the direction cosines concept comes into picture. If the very line is making alpha angle with the x-axis, that means L is cos alpha, M is cos beta, and N is cos gamma. Now L square plus M square plus N square, sum of square of the direction cosines is always equal to 1. So you get cos square alpha plus cos square beta plus cos square gamma is 1. You know that 1 plus cos 2 alpha is 2 cos square alpha. So 1 plus cos 2 alpha upon 2 plus 1 plus cos 2 beta upon 2 plus 1 plus cos 2 gamma upon 2 is 1. This when you solve, you get cos 2 alpha plus cos 2 beta plus cos 2 gamma is minus 1. Why? Because you get 1 plus 1 plus 1, 3. 3 by 2 you get 1 by 2 plus 1 by 2 plus 1 by 2 is 3 by 2. 1 minus 3 by 2 is going to give you minus 1 by 2. Then again 2 is going to go that side, is going to give you just minus 1 by 2 into 2, which is minus 1. So that's how you get the answer, that it is equal to minus 1, that is the value of cos 2 alpha plus cos 2 beta plus cos 2 gamma. So a very little petty concept about direction cosines, that the sum of square of direction cosines is 1. What does the next question say? It says that if OA is equally inclined, OA is equally inclined to OX, OY and OZ, and if A is root 3 units away from the origin, then the coordinates of A are what? So see, if there is equal inclination with X, Y and Z axis, that means just now we did alpha is same as beta is same as gamma, whatever that angle is, it is the same. So L is cos alpha, M is cos beta and N is cos gamma. So that means L is equal to M is equal to N. I just told you L square plus M square plus N square is 1, but L is same as M is same as N, so I get 3 times L square is 1, or L is 1 by root 3. Same is M and same is N. You should know that if you are aware that the vector is root 3 units away from the origin, in that case, and you are aware about the direction cosines also, I can write this as magnitude of OA vector times Li cap plus Mj cap plus Nk cap. What is this magnitude? It is root 3. Li cap means 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. If you multiply root 3 inside, you get I cap plus j cap plus k cap, and if this is the position vector of point A, what are the coordinates of point A? OA vector means so is the origin, so is the position vector of point A. So what are the coordinates? 1, 1, 1 are the coordinates of point A. What are they? 1, 1, 1. And that completes our discussion about the questions on this chapter. Please practice nicely. That's it from my side. Thank you.